My dear children, now in the earlier chapters, we discussed about the chemical reaction, right? In the earlier chapter, we discussed about the chemical reactions. How to identify chemical reactions? What kind of a thing is going to happen in a chemical reaction? If a chemical reaction is going to occur within a system, what are the observations that we can see, right? So those are the things that we identified in the previous chapter. Now within this chapter, we'll be discussing about what sort of a thing is going to happen in the mass of substances during a chemical change, right? During a chemical change or after a chemical change, is there any change in the mass, or is there nothing? Is there any change in the mass, or else, right, is there a change in the mass? So after the chemical reaction, we'll be discussing or we'll be investigating whether there is a change in the mass or not. So first of all, you are given with an experiment, right? We'll be discussing about the law of conservation of mass in here, right? This is the main topic. You ignore about law of conservation of mass. For now, you just ignore about that topic, right? So I'll take the slide somewhat up. Don't focus about that thing. Okay. Let's focus about this question which is given in here. What is that? Is there a change in mass during a chemical change? During a chemical change, is there a change in the mass? Now in the earlier activities, when I'm going to heat that lead nitrate thing, when I'm going to add piece of zinc to sodium, to hydrochloric acid, right? Then after that, when I'm going to add sodium hydroxide with copper sulfate solution, right? When I'm going to take a piece of paper and burn it down. All of those cases were chemical changes. So is there any change in the mass, right? Is there any change in the mass during these chemical reactions or chemical changes? Obviously, you would say yes. You know that when I'm going to burn that piece of paper, ash is going to form. And if I'm going to measure the mass of ash and the mass of paper, those things is going to be different for sure. And if I'm going to take a piece of firewood and I'm going to burn it, initially, definitely the firewood should have a greater mass, but after burning it, mass would reduce, right? So you would say yes, definitely there is a change in mass during a chemical change. But let's investigate about this thing further, right? And let's see within a system during a chemical change whether there is a change in mass or not. And if there is a change in mass, how we can identify it? If there is not, then what are the, what kind of a thing or what kind of a support can be given in that case? So let's head on to the experiment, my dear children, and let's see whether there is a change in the mass or not. So here we are going to find out whether there is a change in the mass during a chemical change. So you will be needing these materials first. What are the materials? Iron wool. Iron wool, right? You will be needing 2 iron wool, right? Iron wool is made up with iron. It's like a wool kind of a substance, like threads, right? It's like iron threads, small pieces of threads like cotton wool, but in some kind of a cotton wool like thing made up with iron wool. Okay, then strings. You need to hang this iron wool at the either side of this wooden rod. Okay, so to hang these two, you'll be needing strings, then a wooden rod. If you don't have a wooden rod, you can find any material, right? The material mean it can be a piece of metal also if you want, right? We need to make up a balance like this. You have to take that wooden rod and you have to hang these two iron wool at the either sides like this. Then by using another piece of string, right, you can hang it and you have to balance these two. Okay, it should be well balanced like this. So this is the way of setting up the apparatus. Okay, right. So my dear children, here we go. These are the materials you need: iron wool, strings, and some wooden rod. Right. So let's see how to conduct this experiment. And there is another material that you would definitely need, that is spirit lamp or else a Bunsen burner. We need to burn one end. Okay, we need to burn one end of iron wool in here. So therefore, you will be needing a spirit lamp or else a Bunsen burner to burn iron wool. Okay, right. So keep that thing in your mind. Okay, so let's move on to see the method then. See the method. Take two equal masses of iron wool and lump them loosely. You have to fit them loosely like this, given in the figure. It's given in the figure, you can see it. Using the two iron wires means the strings, right? Tie them to horizontal rod as shown in the figure. So according to the figure, by taking that wooden rod, you have to tie them at the either side like this. Okay, suspend the rod on a support to balance it horizontally. Light one lump of iron wool. Now you have to burn one lump of iron wool. Right, so this is the way of doing the experiment. Quite simple, but you have to do, just take the two lumps of iron wool and you have to tie them at the either side of the wooden strip or wooden stripe like this. Then take another piece of string and keep the wooden strip horizontally like in the figure. Then after doing all of these stuff, take the Bunsen burner or else the spirit lamp and burn one end according to the figure. And then you have to observe what's going to happen within the system. What kind of a thing is going to occur for the balance of these two iron wool lumps. Okay, so that's the way of doing the experiment. So my dear children, let's head on to the lab. We'll arrange these apparatus and let's light up one end and we'll see what's going to happen after one end is being lighted up. Whether the balance is going to lose or whether the balance is going to keep the same way as it was, right? So we'll head on to the lab and we'll conduct our experiment. Right, my dear children, now we are about to conduct this activity. So in this activity, I have set up my apparatus. So I have used a stand, and by using a thread and a small bit of a string, right, I have created this setup. At the two ends of the strings, I have created two balls of iron wool, and these iron wool are fixed to the two ends of the string. See, these are iron wool, right? Now what I'm going to do is I'm going to ignite one end by using this spirit lamp, and you can observe right now you can observe the string is in a horizontal position and it is well balanced. Means that we can say mass of this end is equal to the mass of other end. That's why it is kept in a balanced situation like this, right? So now what I'm going to do is, so you can see it's in a horizontal position. Now what I'm going to do is I'm going to heat this up. I'll hold the string and I will heat this thing up somewhat. So here you can observe the iron wool is going to give out some kind of a red color, and it's getting burned with a red color. Right, now let's see what has happened to the balance of the system. Now here you can observe this end, it has some kind of a black color, brownish black color. You can see it very clearly, and this end, it has a shiny nature. It's because that this end, after I'm going to burn this end, after burning this end, now this end has iron oxide. In the earlier case also I told you that if I'm going to burn something, oxygen is getting reacted with the substance. So due to that, the color of this one has got changed. This end, we can observe iron oxide. And in here, this end, you can observe it has a shiny surface, still has a shiny surface other than the other end. And if you check the balance of this one, now you can see it's somewhat slanted to the other side. Somewhat slanted, not that much of a one, but it's got somewhat slanted to the end which has got burned. So in this case, we can say that after the burning, mass of this iron wool has got increased. That's why this rod is not in a balanced horizontal situation. Right, my dear children? So we conducted the activity at the lab. You could observe the balance of the system is going to disappear after lighting the first, or after lighting one lump of iron wool. Why does the balance is going to lose? Or why does the balance is going to disappear when you are heating this iron wool lump? It's because that when iron wool is going to burn, a chemical reaction is going to occur, right? When iron wool is going to burn, you know that during a burning, right, during a process of burning, I told you in the earlier case also, when I was burning magnesium with oxygen, or when I was burning magnesium in atmosphere, I told you that magnesium is going to react with oxygen gas in our atmosphere, creating magnesium oxide. In the same way, if you burn certain thing, it is going to interact with oxygen gas in the environment. So during that process, new substances are getting created. Basically, those things could be oxides, right? Those things are called as or referred as oxides, like magnesium oxide. So my dear children, when iron is going to burn, iron oxide is getting created. Okay, iron oxide is going to create. The thing is that iron oxide has a greater mass than iron. So therefore what happens here is, after the burning process, or when iron is going to burn up, iron oxide is going to form. Iron oxide is heavier than normal iron. So therefore the balance will disappear. So the observation was quite simple, my dear children. See, iron wool burns, giving reddish sparks. You could see that there was reddish sparks, right? Same time, the side with burnt wool moves down. Burnt wool is going to move down like this. Right? Like this. So this is the burnt one. Right? This is the burnt side. It's going to come down. Means that it has more mass. And this one, this side has less mass. As this side has more mass, right? It comes down. Why does it carry more mass? In the earlier case, it was under balance, no? So why does it going to have a more mass? Because, my dear children, we burnt it, right? During the burning, chemical reaction or chemical change has got occurred and new substances were got created. So those new substances now heavier than the initial substances. So therefore, this would come down. So the conclusion, see, when iron wool turns into the products of combustion, combustion means the burning. After the burning process, you know that I told you earlier also, iron is going to convert into products. Iron oxide in simple. So when iron wool turns into the products of combustion, the mass increases. See, it carries more mass. That's why it's going to come down, right? So my dear children, within this experiment, it's obvious to us. What is that? What is our final conclusion then? During a chemical change, right? In this experiment, there is a change in mass. Here the mass has got increased, right? Mass has got increased. Okay. So my dear children, during each and every chemical change, does the mass is going to increase? In each and every one? Now this is one type of a chemical reaction and that's it. No. Burn in iron wool, right? There are lots of chemical reactions in our day-to-day life, no? And in environment also there are different types of chemical reactions, no? So are there any other change? I mean, like for an example, if the mass is going to reduce during a chemical change, right? Does the mass is going to reduce? Always is it increasing? Let's see whether there is a decrease in mass or not. So our next activity is to see whether there is a change in the mass, but especially in here we are investigating whether there is a decrease in mass or not. Okay. So to conduct this activity, you will be needing these materials, right? To conduct this activity, you will be needing these materials. What are the materials? First of all, so once again, don't think about the topic, okay? Don't think about the topic. I'll be explaining about the topic for you guys very well when I'm going to finish up with these experiments, okay? So don't think about with the topic just for now. Just focus on the topic given in here under the activity 2. Is there a change in mass during a chemical change? That's our main topic, huh? Remember it. Okay, so here we are going to identify whether there is a change whether there is a reduction of mass during a chemical change. Earlier there was an increase in mass in earlier activity. Now let's see whether there is a reduction or not. So to conduct this activity, you will be needing these materials. What? You will be needing matchsticks, right? Actually, we will be needing several heads of matchsticks. Okay, so I'll put matchsticks. That's okay. And a boiling tube. Boiling tube. So these are the two materials you need, and plus, now here we are checking about the mass, no. So to check the mass, you will be definitely needing a balance. Okay, you will be definitely needing a balance to check the mass, the initial mass and the final mass. Okay, right. So keep that one in mind also, my dear children. So in the lab, we'll be using more sensitive, right, more sensitive instruments to measure masses. Especially, we'll be using electronic balancers, right, more sensitive. It can measured up to like 2 decimal places of grams, right? So therefore, when we are conducting this activity, when we are getting some idea about the mass, it's really important to have such kind of a more sensitive instruments as well, right? It's difficult to use or difficult to get some observations if you use like analog instruments. Okay, analog instruments means we have to put some weights to a side, then we have to get the measurement and we have to keep it like this. Okay, in retail shops, the local balancers that we use in our retail shops, those balancers cannot be used in these experiments, my dear children. You can use up to a certain extent, but you won't be able to get more proper observations if you use those kinds of stuff. So it's better to use a very good chemical balance or else a digital balance, an electronic one, which is more sensitive with the really small change in masses, right? So in the lab, we'll be using a more sensitive kind of a balance, right? Okay. So matchsticks and boiling tube. Then to measure the mass, you'll be needing a balance, a good sensitive one, electronic one. Okay. So the method, put a few heads of matches to a boiling tube. Okay, you have to put several matchsticks to the boiling tube. You can take the head of it. Okay, only you can take the head of it. You can cut off the head and put that head into the boiling tube. Okay, then weigh the boiling tube with them. We have to weight it, right? By using the balance, we have weight and we have to record the mass of it. Okay, heat the boiling tube strongly with an open flame until match heads catch fire. Then what do you have to do? We have to heat the boiling system very well by using a spirit lamp or else a Bunsen burner. You can heat the system, right? You have to put those matchsticks into the boiling tube. Then we have to heat it. But before heating, remember to note down the mass of it. Okay? Then heat it. Then, after cooling, weigh the boiling tube with its contents and record your observations. Then you have to record the observations after the process, after the catching, after it's going to catch up with fire, and let it cool for some time, and then after that you have to measure the final mass of it by using the balance. Okay, so it's easy to conduct the activity. Take some matchsticks, put those things into the boiling tube, measure the mass. Okay, then heat the boiling tube very well, light up all the matchsticks, allow it to cool for some time, measure the mass. Compare the two masses separately and see whether there is a change or not. Okay, so that's the way of conducting the experiment, my dear children. So let's head on to the lab and we'll conduct the activity and let's see whether there is a change, whether there is a reduction actually in the mass or not. So my dear children, in the earlier activity we discussed that now during the burning of iron wool, mass has got increased, right? So now I am about to conduct another activity to see whether there is a change in the mass during a chemical reaction or during a chemical change or not. So I have these materials. First of all, in here I have a balance. This is a digital balance, right? And it is very sensitive. We can measure up to 2 decimal places, and here you can observe it's printed grams. It's been printed as grams, G. So here the mass is given from grams. Very sensitive digital balance. So on the balance there is a petri dish and you can observe now the scale at 0. Now the scale is at 0. So now what I'm going to do is I'm going to take a boiling tube and I'm going to insert some, see, these are matchsticks and I have removed the tail of it and I have only the head of it, the burning part. So what I'm going to do is now I'm going to put these heads of the matchsticks into the boiling tube. Now I'm going to measure the mass of this system like this. By placing it very steadily on the digital balance, I'm going to measure the mass of it. So here it's been printed on the screen 29.60. So the total mass, the entire mass of this boiling tube which contains the matchsticks heads is equal to 29.61, right? We'll get an accurate answer. Okay, 29.61 is the answer. Okay, right, 29.62. See, it's very sensitive. That's why I told you it's very sensitive. So we have to keep all the systems very steady. Otherwise the mass will reduce or increase. We can't get a clear observation. So final value of the digital balance is now 29.62. 29.62 grams. You can observe it on the screen here. It's been printed 29.62, right? Okay, so now I'm going to take the boiling tube away, and what I'm going to do is I'm going to heat this up and burn all the matchsticks inside the boiling tube. So and let's heat up. Right. So now what I'm going to do is I'm going to take away the boiling tube. Here you can see a smoke is getting emitted. See, a smoke is getting emitted means that a chemical change has occurred in this system. Now let's measure the mass of the system right now. So in the earlier case, my dear children, you could observe 29.62. 29.62 was the answer. But after the chemical reaction, I can get a clear observation. It's been reduced to 29.53. Means that some amount of mass has been reduced during this chemical reaction or during this chemical change. Some amount has been reduced. So in the earlier activity, some amount has been increased, and in this activity, some amount has been reduced. From 29.62 to it has dropped 29.52. Here you can observe 29.52. This is the final answer, 5352. Okay. So let's see, or let's once again let's head on to the classroom and let's write down the conclusion and the observation of our experiment. Right, my dear children, now you could see that when I was doing the experiment, right, you could clearly observe that the mass has got reduced, right? The mass has got changed. After I'm going to weigh the system, mass has got slightly changed. Changed means here mass has got reduced, right? So it's going to be a trouble now. Actually, what kind of a thing is going to happen during a chemical change? Whether the mass is going to increase or else decrease. In some chemical reactions, mass is going to increase. In some chemical reactions, mass is going to decrease. So we can't come into a final conclusion what happens with the mass, right? So let me clarify this thing, my dear children. First of all, we'll write down the observation and the necessary conclusion in here. Then let's move on with the explanation of these two experiments. And we'll see actually what has happened here. And how does the external system is going to affect for the chemical change that occurs here. Okay, there's an impact, a big impact between the external environment and the system in which the chemical change is going to occur. Because now during the creation of new substances from the environment or within the system is going to interact each other, no? So in that kind of situation, external environment is also should be considered. So the system which the chemical reaction is going to occur is going to give a good impact for the masses and for the substances which are going to produce as well, right? So first of all, we'll write down the observation and conclusion in this activity, and let's go into the explanation of these two activities. Right, my dear children. So what is our observation from this experiment? What is our observation? Our observation was quite clear. Mass has got reduced after the burning of matchsticks, right? Mass has got reduced after the burning of matchsticks, right? So this is the observation. So conclusion. What is the conclusion? During chemical changes, there can be reduction in masses as well, right? In this chemical change, there is a reduction in mass. There is a reduction in mass when reactants are converted to products. So my dear children, in this chemical change, there is a reduction in mass when reactants are converted to products. Right? Two experiments, two chemical reactions, two different observations, two different conclusions. One, mass got increased. Two, mass got decreased. Let's move on to see what is the explanation for these two experiments. So my dear children, the problem is here. You may have the problem why there was an increase in the mass when iron wool was burnt in activity 1, while a decrease in the mass was shown when the match heads were burnt in activity 2. In above experiments, the substances were burnt in open environments. What environments? Open environments. Open environments. What kind of a thing is called as an open environment? Open environment means it's like this. A system which is like this. This is particle A. This is particle B. Within a system, okay, these two are interacting each other to create the new particle AB. Okay, a system, see, particle A, particle B reacts together to create particle AB in a system. Speciality in here is that, okay, I'll draw another one. This is particle B. I'll take a different one. This is particle D. This is particle C. Together they create particle CD. Like this. And this outline is the system or the environment where the chemical change or these reactions are going to occur, my dear children. The first one, this one, where A and B going to react to create AB. System is closed entirely. Substances from external environment cannot enter to this system. Right? And the substances which are getting created within the system cannot exit outside. See? Can't enter, can't exit, as it is closed entirely from all around the space. Okay, first one. So, particles will not freely exchange between the external environment and the system where the chemical reaction is going to occur. There is no entry, no exit between the particles, as the system is completely closed. This kind of a system is called a closed system. closed system. During the reaction of C with D to create CD, this system is open to the external environment. See, this side is not covered. Means that particles can freely enter to the system. New particles which is getting created within the system can exit to the outer environment also. Right? So this system where the newly produced particles can exit to the outer environment, plus particles from the outer environment can enter to the system. Right? This kind of a system is called an open system. Open system. Particles can freely move here and there. Particles can move freely to the external environment, and the particles which are getting produced within the system can also move to the external environment. Particles from outside should also have an ability to come inside to the system. Open system, open environment, open system. The particles which are getting created here do not have an ability to exit. And the particles which are located outside the system cannot enter to the system as well. Means simply entry and exit of the particles is prohibited, or it's been closed down. There are no entry and exit between the particles with the external environment and the system which the chemical reaction is going to occur. That's why I told you, my dear children, the environment, it's really important. It's playing a huge factor, or it's playing a huge impact. It's giving out a huge impact upon chemical reactions, because during chemical reactions, during the formation of new substances, exchange of particles could happen between the external environment and the system itself. So therefore, it's really important to have, right? It's really important to have the system or the unit. Like, what kind of a system is the system that we are going to carry out the chemical reactions? What sort of a unit is it? That factor is really important for the chemical change, right? So if the chemical changes are occurring in a closed system like this, where the entry and exit of the particles are not going to occur, right? Okay, in these kind of systems, in these type of chemical changes, mass would be a constant. Mass will never, right? Mass will never change. But my dear children, if the system is an open system like this, newly produced particles can exit through the system. So there are some certain cases where we can measure the mass and where we can't measure the mass in certain substances. Imagine that in here, a gas is going to emit. You know that gases are type of matter. Matter has some kind of a mass. So if gases are going to evolve in this reaction, the gas is going to release to the external environment. So how come we could measure the mass of it? Definitely then the mass should change. That what has happened in the earlier activity where I was burning matchstick's head by using that boiling tube. When I was burning it, I didn't close the boiling tube. I opened it to the environment. Upon burning, smoke is going to emit. Smoke is a type of a gas. Gas has a mass. So definitely there should be a reduction in mass after the chemical reaction. In the first activity, right, when I was burning iron wool, you know that iron oxide is going to form oxygen coming out from the environment. So when oxygen is going to combine with iron, definitely the mass should increase. Because earlier it was only iron, now during the burning, oxygen is going to combine with iron. So new particles are going to join from the external environment as it is an open one. Right? So my dear children, during chemical changes, if the system is an open system, in those chemical changes, definitely a mass change will occur. Definitely a mass change will occur. But if it is a closed system like this, then there is no change in the mass. There can't be a change, because if the system is closed, all the materials which are created, all the materials which are initially bought were in the system, and there is no escape, and new particles also can't enter, then therefore the mass should be a constant. It can't change at all. So my dear children, see, when the substances react, there is a chance to combine with some substances in the environment and also to release products of the combustion to the environment. So in open environments, there is a possibility to add substances from external environment to the system, plus the substances which is getting created within the system, they also can exit to the external environment. Means there can be change in the mass in open systems like this, right? An increase in mass occurred due to addition of some substances from the environment. I told you in the earlier case, when I was during that process where we are going to burn iron wool, oxide or oxygen gas from the external environment is going to combine with iron wool to increase the mass. So oxygen is coming out from the environment, right? Oxygen is coming out from the environment, from the closed system, from the open system. It is being exposed to the environment or the atmosphere, no? So oxygen is coming out from the atmosphere to combine with iron to create iron oxide, right? So my dear children, mass has got increased in that case because oxygen who came out from the atmosphere is going to combine with iron, right? A decrease in mass was noticed due to loss of some substances to the environment. When I was burning matchsticks, that smoke which is coming out from the system, smoke means gas, gas means matter, matter has a mass. So when smoke is going to emit from the system to our environment, there should be definitely a loss in mass. So that's how the mass has got changed in those two experiments. In the first experiment and even in the second experiment, in both the cases, we did those chemical reactions in open environments. So in open environments, my dear children, if a chemical change is going to happen, definitely mass is going to change as new substances are getting created with the external environment, or new substances which are formed is getting released to the external environment as the system is not closed, right? So let's see what will happen if I am going to conduct chemical reactions in what? Closed systems, right? So before that, you are given with what do you mean by open and closed systems. So once again, see, open systems, So the systems in which the substances can exchange between the system and the surroundings, means the external environment. Particles can exchange between the external environment or the surroundings with the system. So these are referred to as open systems. Second one, closed systems. The systems in which the substances cannot exchange between the system and the environment are called closed systems. Right? Closed systems, open systems. Then, to find out whether a change occurs in the total mass of substances taking part in a chemical reaction, the experiment should be conducted in a closed system. Otherwise, we can't get a clear idea, because our readings would be faulty. If you conduct experiments, or if you conduct the change in masses, if you conduct an experiment to check whether there is a change in masses in an open environment, then definitely we will be getting an answer, a positive answer for the change in mass. So therefore, it's important to conduct these experiments in a closed environment. So, to find out whether a change occurs in the total mass of the substances taking part in a chemical reaction, the experiment should be conducted in a closed system in which substances are neither gained nor lost from the surrounding. Right? So it's important to carry out experiments like that way. Like what way? We have to carry out these chemical changes in closed systems. Right? So let's carry out experiments in closed systems and let's see whether there is a change in mass or not. Okay. So my dear children, before going to conduct these experiments in closed systems, now I am going to explain what do you mean by that first and foremost topic, the law of conservation of mass. Law of conservation of mass means really a simple thing. See, during chemical reactions, the total mass does not change. That means the mass is conserved, but my dear children, it should be a closed system. In a closed system, if you carry out chemical changes or chemical reactions, there is no change in the mass. Mass would remain the same. There is no change in the mass. Right? There is no change in the mass. Mass definitely would remain the same if you carry out chemical changes in closed environments. Right? So this process or this theory in which the mass is getting conserved during a chemical reaction is called the law of conservation of mass. Means that during a chemical reaction, if the chemical reaction is going to occur in a closed system, not in an open system, it should be a closed one, right? So in a chemical reaction, during a chemical reaction, if the chemical reaction is going to occur in a closed system, the total mass is conserved, means not changed. This principle is called the law of conservation of mass. If you take our earth, my dear children, our earth is a closed system. Right? Our earth is a closed system. If I am going to carry out an experiment over here, and when I am going to conduct the experiment, let's assume that it is a chemical change. You know that particles are going to exit or particles are going to combine. However, no matter how much of chemical reactions which I am going to perform within this place, the total mass of the earth is not going to change at all. Right? No matter how many chemical reactions are going to occur within this earth, the total mass of the earth is not changed. Total mass of the earth, of our earth, is not going to change at all. It remains the same, because whatever the particle which is getting exit from the chemical reaction is going to remain within the earth. It's not going to escape from the earth, right? And the new particles cannot enter to our earth from externally. So therefore, right, earth is a closed system. So each and every chemical reaction which occur in our earth, the total mass is getting conserved, or the total mass is not getting changed. This principle is referred as the law of conservation of mass. Law of conservation of mass means during a chemical reaction which occurred in a closed system, the total mass is getting conserved. It's not getting changed. This is what do you mean by the law of conservation of mass. But remember, my dear children, it should be a closed system. Right. So let's carry out now some experiments in closed systems, and we'll see whether the law of conservation of mass is true or false. Right. So testing this law of conservation of mass. Once again, now we are about to carry out that experiment where we burned matchstick's head. Okay, but this time we'll be doing that thing in some kind of a different way. So testing law of conservation of mass, we'll be needing these materials. Once again, you'll be needing a boiling tube, then matchsticks, then a balloon. Why do you need a balloon? Because by using the balloon, I'm going to now cover up the boiling tube, right? I'm going to place this balloon over the boiling tube like this, so that the gases or the smoke, whatever the products which are going to produce after the burning process, would not escape to the external environment. I'm going to close it down. I'm going to enclose it by using the balloon. Okay? Right, my dear children. So the experiment is similar to the earlier one. Only thing that we are going to change in here is that I'm going to insert this balloon to the boiling tube, and I'm going to, first of all, I need to insert some matchsticks into the boiling tube. Then I'm going to cover up the open end of the boiling tube by using the balloon. Then I'm going to measure the mass, right? Then I'm going to measure the mass. Then what I'm going to do is I'm going to heat the boiling tube very well until the matchsticks are going to burn. You know that after sticks are going to burn, smoke will going to emit. So when smoke is going to emit, the balloon should inflate, right? It's because that gases which are coming out from the system is not getting exited through the balloon, no. So therefore, the balloon should inflate. Okay. Then I'm going to measure the final mass of it and compare the initial mass with the final mass after the chemical reaction and before the chemical reaction. Let's see whether there is a change in this time or not. If I'm going to conduct the experiment accurately, then there shouldn't be any change, as this is a closed system, right? Through the balloon, external environment, particles in the external environment can't enter to the boiling tube, and whatever the products which are getting created within the boiling tube cannot exit to the external environment through the balloon. So it's a good closed system. So thereby we should get a same answer even and after measuring the masses after this chemical reaction. Right, so we'll head on to write down the method, my dear children. Now method is given. See, balloon, the boiling tube, matchsticks. See, the balloon is being fixed. So let's see the method. As shown in the figure, close the mouth of the boiling tube containing matches with a balloon. Measure its mass. So first of all, this system, in this system, the figure in here, you have to measure the mass of it. That's the first step. Okay. First step, you have to measure. You have to set up the apparatus according to the figure. Then you have to measure the mass. That's the first step. Definitely, you have to measure the mass and record it down, my children. Right? Definitely, you have to measure the mass in this step, and you have to record it down. How much is the value of it? Okay. Then apply heat close to the bottom of the tube until the matches light up. So till matches are going to light up, we have to heat it at the bottom, near the bottom of the boiling tube. Then allow the boiling tube to cool and weigh again. Then after the chemical reaction, let it some time to cool. Then measure the total mass. Okay. So it's really simple. Place the apparatus like in the figure. Weigh the mass. Note it down. Heat up the boiling tube. Allow matchsticks to burn up. Let it cool for some time. Again weigh the mass. Compare the two masses, whether there is a change or not. So this is the way of doing the experiment, my dear children. So let's head on to the lab and we'll conduct the activity and let's see what are our observations. Right, my dear children. Now, in the earlier two situations, we conducted or we did the chemical change. We did a chemical reaction in an open environment. Means that particles can freely enter to the system or freely enter to our unit, right? And particles which is contained inside the chemical reaction, whatever the particle which is getting newly produced, can exit through the system, right? So that kind of a system is the one which is referred as an open system. So in the earlier two cases, we conducted open system chemical reactions. Okay, we did chemical reactions in an open system. So when I'm burning matchsticks, you could observe that the smoke is getting emitted from the system, from that boiling tube. Now in this activity, we are going to enclose the entire system, and now let's identify whether there is a change in the mass of the materials or not after the chemical reaction. So once again, I have these materials: boiling tube, a balance, a digital balance like in the previous cases, a spirit lamp, some matchsticks. Once again, I have used the heads of it, right? And a balloon to enclose the top of the, or to enclose the boiling tube. I have a balloon. So these are the materials that I have, and I'm going to conduct the experiment right now. So let's see. First, I'm going to take the boiling tube and I'm going to insert these matchsticks into the boiling tube. In the next step, so I'll remove these things. In the next step, I'm going to insert this balloon on the boiling tube like this, so that the gases will not enter to our system, or after burning these things, the gases created inside the system will not go outside also. So I have enclosed it. So now I am going to place it on the balance. And let's measure the mass of the system. So let's measure the mass of the system. We'll keep it somewhat steady to get a clear answer, to get a clear value. So here you can observe the digital balance is printed. The value is being printed as 32.57. So my value is 32.57. Right? So remember the number, children. 32.57. That's the mass of this system. Now I'm going to take it out. And I'm going to heat up this boiling tube. So when you know that when I'm going to heat this boiling tube, the matchsticks heads inside the boiling tube will burn out and they will undergo in a chemical reaction. Right. So I'll heat it by using the spirit lamp in here. Right. Now my dear children, I'm going to measure. So I'll enclose this thing. Now my dear children, I'm going to measure the mass of it. Right, my dear children. Now I have placed it in here. Here you can see the balloon has been inflated. See, the balloon has been inflated. All the smoke coming out from the reaction is being filled into the balloon, and the amount, see the amount, 32.57. So the amount or the mass haven't changed in this time. Mass haven't changed in this time. So now why the mass haven't changed in this time? Because the gas or the whatever the smoke which is coming out from the system now is being filled to the balloon. So there is no mass which is getting released to the system or released out from the system to our environment. No mass. You know that gases or smoke is a type of a material. It's a type of a matter. Almost all the matter, 100% of matter in our environment, they have a mass. This digital balance is very sensitive. So even we can measure the masses of the gases as well. So when the system is opened, the smoke which is coming out has a mass. So that's why the reduction of mass occurred in the earlier case. Now that gas is being filled into the balloon here. So therefore, there is no loss in the mass. There is no loss in the mass because all the gases which is emitting to the environment, now we have collected it to the balloon. So in a closed system, there is no change in the mass, right? So we'll conduct another activity to ensure that our result is correct. Right, my dear children, so we conducted the activity and you could clearly observe that there was no change in the mass even after the chemical change, right? So there is no change in the mass during the chemical change. As I was told earlier, right? When I'm going to heat up the boiling tube, the balloon got also inflated because the smoke which is coming out from the system is going to fill onto the balloon. So my dear children, it's obvious to us that in a closed system, there is no change in the mass after a chemical change. So we'll write down our observation and conclusion then. balloon got inflated. There is no change in the mass. There is no change in the mass. System. Right? So balloon got inflated. That's the first observation. The second one, there is no change in the mass of the system. There is no change in the mass. So what is our conclusion then finally? In a closed system, right, mass is conserved or mass is not changed, right? In a closed system, total mass is conserved. Conserved means not changed. Preserved is also correct. Mass is preserved, not changed, not getting changed at all. Preserved or conserved. So in a closed system, total mass is conserved during chemical reactions. In brackets I can include like this: mass will not change. Mass will not change, right? So in a closed system, total mass is conserved during chemical reactions. In a closed system, total mass is conserved during chemical reactions, means mass will not change in chemical reactions if the chemical reactions are going to occur in closed systems. So this is our final conclusion from the activity, right? So that's why the mass is not going to change. So in closed systems, even after chemical reactions, the masses will not change at all, right? Right, my dear children. So the second activity to identify or to show that law of conservation of mass is true. In this activity, we'll be using several chemicals, right? So first of all, we'll see what are these chemicals. We'll be needing salt, right? Salt. The chemical name for salt is, sodium chloride. Water, lead nitrate, okay, then a flask, ignition tube, ignition tube means it is also a type of a boiling tube, a small bit of a boiling tube like this kind of a size. It can be heated up to very high temperatures to melt metals like sodium metal. We can use these ignition tubes. They are very small, right? It can be heated up to very high temperatures to melt metals. We use ignition tubes like the crucibles, right? Ignition tube. So these are the materials you need: a flask, some salt, or sodium chloride, water, lead nitrate, ignition tube, and some clay or Vaseline or wax or whatever to seal. We need to seal up the flask. Okay, and also a piece of cork, right? A piece of cork to fix inside the flask so that it would seal up. So these are the materials. Main materials are these. Except for these things, you'll be needing some amount of wax or clay, right? Some Vaseline is also okay, and a cork to fix onto the flask so that it would close up. Okay, so let's see how to conduct the activity. Okay then, so this is the way of conducting the activity. See, you are given with a figure. Take that flask. You have to include the sodium chloride solution into the ignition tube, then lead nitrate solution into the flask like this. Take a piece of thread and keep it like that way and hang that sodium chloride solution within the flask. Then we have to fix that cork and we have to seal it by using wax or Vaseline or whatever material from the top, so that it should be a closed system, right? So my dear children, let's see what is the method in conducting the activity then. Take about 1 gram of lead nitrate to a conical flask and dissolve in about 20 ml of water. The conical flask, this flask is also called as the conical flask, right? That conical shape, due to that conical shape, this is called as the conical flask. Okay, then take about 1 gram of sodium chloride to a test tube. Dissolve it in about 5 ml of water and transfer the solution to an ignition tube. Sodium chloride to the ignition tube according to the diagram. Tie the ignition tube with sodium chloride solution with a string and suspend it inside the conical flask containing the lead nitrate solution with the help of a stopper as shown in the figure, right? So according to the figure, you have to stopper it. Then after that, we have to introduce that sodium chloride solution to the conical flask by using a thread. Okay, then seal the conical flask by applying Vaseline or clay around the stopper. Weigh the flask with its contents. Now apply some Vaseline or clay on this surface so that it would seal up quite well. Then after doing all of those stuff, you have to measure the mass, right? You can use a digital balance, right? And we have to measure the mass. Okay, right. Then finally, slant the apparatus slowly and let the two solutions mix. Record your observations. Weigh the apparatus again and note the mass. What you have to do after setting up this thing, you have to slant this thing so that these two solutions would mix up together, right? During this process, a white color precipitate is going to form, right? White color precipitate is going to form. We'll conduct this activity at the lab later, right? Then after, you have to measure the total mass, right? To check whether there is a change in the mass or not. So my dear children, this is the way of doing the activity, right? The second activity to check whether there is a change in mass or not in closed systems. So let's head on to the lab and we'll conduct the activity and let's see whether there is a change in the mass or not. Right, my dear children, now this is the second activity to see whether there is a change in the mass during a chemical reaction in a closed system. So here I have once again lead nitrate. I have lead nitrate with me, right? I have lead nitrate with me, and so I have poured some lead nitrate into the petri dish. So this is lead nitrate, right? And this is in the ignition tube. Here you can observe in the ignition tube sodium chloride. So now what I'm going to do is, first of all, I'm going to add some water, and by using this wash bottle and make a solution of sodium chloride, right? Okay, I'll shake and dissolve sodium chloride in the ignition tube. Right, now by using another flask, I'm going to add some lead nitrate into it. I will use this spoon to get the lead nitrate into the flask. Right. Now let's add some water and make a solution. You have to dissolve it very well inside this container. So we'll dissolve it. So the lead nitrate solution. So I have dissolved lead nitrate in this flask by using water, and I've made a lead nitrate solution here. So now I'm going to keep it here. Then I'm going to take the earlier ignition tube which has sodium chloride. So here you can observe there is some amount of sodium chloride at the bottom still. So I'll shake somewhat. Right. So here you can see in this within this ignition tube there is sodium chloride, and you can see the solution very clearly. I have added somewhat more water to dissolve all the sodium chloride in the ignition tube. Now I'm going to gently insert this thing into this system, very gently, and I'm going to keep it like this kind of a position. Right. So I'm going to keep it in this kind of a position, and I'm going to insert the cork very well so that it would seal up. Right. So make sure to seal the system very well. because I told you that it should be a enclosed system. It should be a closed system. So this is my system now. Ignition tube which contains sodium chloride, and the other vessel, the larger vessel, which contains lead nitrate. Now I'm going to place it on the balance to measure the entire mass of it. So my final value is 175.28. 175.28. That's my final value, 175.28. Right. Now I'm going to take this one up and I'm going to mix the sodium chloride with the solution here. Right. 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 So here you can see it very clearly. There is a chemical change and there is a precipitation inside the ignition tube. Now I am going to place it on the balance and we'll see whether there is a change or not. So my dear children, once again you can observe, even though the chemical reaction has occurred within this system, you can see that there is a precipitation inside the ignition tube. But the mass of the system haven't changed at all. Mass of the system is still at 175.28. So we can finally conclude that then in a closed system, there is no change in the mass even after a chemical change. So here the mass is preserved in a closed system during a chemical change. So this law of preserving mass is called as law of preservation of mass, or else this thing is referred as the law of preservation of mass. So this is how we can say that a closed system do not waste or do not in a closed system there is no change in the mass. So this is the final conclusion that we can arrive from these two experiments. Right then, so we'll head on to the classroom once again and we'll conduct about further things related to this preservation of masses. Right, my dear children. So once again you could observe that there is no change in the mass even after conducting the chemical change, right? So we could see that there is a precipitate, means that there is a chemical change, and even though the chemical change is going to happen, there is no change in the mass at all. So it's obvious to us that in a closed system there is no change in the mass. The entire mass is going to conserve before and after the chemical reaction. So once again you are given with the observation. See, white color precipitate is created when mixing the two solutions. When you are going to mix the two solutions, when I was mixing those two solutions, you could observe that, okay, you could observe that a white color precipitate is going to create. So finally the second observation is mass of the system remains the same. Mass of the system also remained the same, right? So these are the two observations that we took from the experiment. So my dear children, the final conclusion, we conducted two different activities, and in these two activities, right, and in these two activities, both of these two activities, we could observe that the total mass haven't got changed at all. It remains the same. So finally we can say that in a closed system, total mass is conserved. remains the same. Right? In a closed system, total mass is conserved, means it remains the same after a chemical reaction. So in a closed system, total mass is conserved, remains the same after a chemical reaction. So this is our final conclusion, my dear children. We conducted two different activities to show that this law of conservation of mass or total mass is conserved during a chemical change. Right. From above activities, now we did several activities now. So from above activities, it is clear to us that there is no change in the total mass before and after the reaction which occurred in a closed system. In a closed system, there is no change in the mass, right? In a closed system, there is no change in the entire mass before and after the chemical reactions. Okay? So, the important one, the French scientist Anthony Lavoisier, he was a French scientist, Anthony Lavoisier, who lived in 1743 to 1794, who conducted many experiments such as the above in relation to various chemical reactions, showed for the first time that the total mass of the substances taking part in a chemical reaction, means the reactants, right? Those are the substances that taking part in a chemical reaction are called as reactants. Okay, is equal to the total mass of the products obtained after the reaction. Means that if the mass of reactants are 500 grams, then the mass of the products are also 500 grams. There is no change in the mass even after the chemical reaction, right? So later this finding came to be known as the law of conservation of mass. So Anthony Lavoisier was the first person to investigate about these chemical reactions regarding the closed and open systems and to introduce this law of conservation of mass thing. Law of conservation of mass is really important, right? It's a really important factor, right? So my dear children, even after a chemical change, no matter whatever the chemical change, if the chemical change is going to occur in a closed system, the mass of the reactants which are being introduced to the system and the mass of the products which are getting created after the chemical reaction both have the same value. If you take the sum of the reactants, right, sum of the masses of the reactants and sum of the masses of the products, both the masses would have a same value. The mass is not getting changed. The mass is preserved. Mass is conserved, right, in each and every chemical reactions which are occurring in a closed system. This principle or this law is called as the law of conservation of mass. Law of conservation of mass. So law of conservation of mass means this thing, right? So it was founded by, or it was first investigated by the French scientist Anthony Lavoisier, who lived in 1743 to 1794. Right, my dear children? So we got a sound knowledge about what do you mean by this law of conservation of mass, and we got a idea about what are open systems and what are closed systems. We got very good knowledge about the chemical changes. We got good knowledge about the chemical changes and how the mass is going to interact with the open and closed systems during a chemical change, whether there is a change in the mass in chemical reactions or not, right? So like that, we discuss several things regarding chemical reactions in this chapter. So I hope you got a sound knowledge about this law of conservation of mass, right? So in our next chapter, my dear children, we'll discuss further things related with the lesson.